In my last video, we talked about what a schematic is, and we talked about the symbols that you might see on a schematic. We went over an electronic speed controller, a motor, the receiver, battery, switch, LED, resistor, wire, and BEC, or battery eliminating circuit. Now, we want to talk about and look at our schematic. Now, all circuits are going to start with the power source. In our case, that's a 16.5 volt battery. And I have wire coming off of that battery. We have the negative side and the positive side. That battery has a indicator light, and as we mentioned, the indicator light has to have a 1K ohm resistor. I'm going to label it R1, which leads to an LED. To let us know that the battery in the circuit is on. Additionally, we have a circuit that is going to be containing our motors, ESC3. We have our drive motor and ESC. That usually operates the left or right side of the robot. We have ESC2 connected to motor 2, which operates the right or left side of the robot, the opposite side of the previous. We have a receiver, which connects. We have jumpers to our receiver. And that's more or less it. We did forget our switch. I'll explain this momentarily. Now, we've tried to simplify this circuit as much as possible. So, what you currently are looking at is that you have a 16.5 volt battery that the electricity flows out of from the negative side of the battery, and it stops at the switch. Once the switch connection is made, the electricity can flow out and down two paths. This is a parallel circuit. The first path of that parallel circuit is the indicator light, which contains the resistor and the LED, the light emitting diode, to let us know that the power is on in the circuit. The second leg of that parallel circuit is the one that contains our drive system and weapon system. The indicator light is not tied in series with our circuit because, in the event that it was, and the LED or the resistor blew out, the entire circuit would stop working. Additionally, with the resistor and LED in place, and if they operate on such a low voltage, we would have a 16-volt battery reduced to about 3 volts, and our entire system would be dependent on the 3-volt system. So that would not be enough to power our ESCs, motors, and weapon, any of that stuff. So we have a parallel circuit with the LED and the indicator light, and we have a separate leg, as mentioned before, with the ESCs and motors. The first ESC that we come to, the power can travel through it into the motor, and then it's connected into the other side of the circuit. Same with both of the other two ESCs. The first ESC we have, you can see powering the receiver, and that might even be marked with 5-volt BEC line, identifying that it is a 5-volt line connecting to the receiver and powering it. Now, the other ESCs also have BECs built into them, so in some cases we disable that by cutting a wire on those ESCs. So when you're actually wiring up the robot, you do need to pay attention to the fact that we would have one electronic speed controller that has the wire still intact, and the other two ESCs would be disabled, or the wire would be cut. And that only is the case in the event that the other two ESCs, battery eliminating circuit, if they interrupt or cause disruption with operation of the receiver, then the wire is cut. If they're able to talk to each other and avoid this feedback or disruption, then we leave the wires intact in the event that we would need it in the future. That is our basic circuit for our robot.